All right, we back in this thing, eh? What's going on? Welcome back. It's been a few days here, huh? Hold on, let me get my headphones. I got my headphones. Okay. What up? Hello, everybody. I'm back. I'm back. I'm back. I'm back in the stream. Oh, what's going on? It's cold here in my apartment. Man, it be cold here. Let me tell you. Uh, the temperature swings here in California. Tough here, man. I wanted to talk. Some of y'all are dealing with some rough temperatures out there, so I'll keep it short on that front. But to me, it's cold out here. I need a haircut, bad. Looking real rough around the edges here. I'm not gonna lie. Um, Getting into the programmer stereotypes, right? Um, growing out the hair, beard, neck beard. Not a good look here. We need to trim it up and probably clean it up. In case maybe something rolls around where we need to be presentable. So that'll be my assignment here for this weekend. Get trimmed up. Anywho, welcome back into the stream, everybody. Hope you're having a good day. Um, uh, it's December 30th, so hope you guys had a good Christmas. Um, I believe I streamed since then. Yeah, it's been I can't remember the last time I streamed on it. It's been a little bit bad for me. I've been slacking lately. I just been enjoying the time here with my girlfriend as over the holidays, and I don't really get many back-to-back days where we can just hang out and really, bond and whatnot. So, because it's, we're struck by being in two different places and having to deal with all that jazz, and so it's nice to finally get some like a break from that and what a taste of what it could be, eventually if we can financially break out of, the spells of of modern economies. Okay. Anywho, let's get started here today. So we're going to be back in C Programming: A Modern Approach, second edition here. Let me actually open up the book. I don't have that opened up for some reason. Come on, man. Where is it? No, it's on my desktop here. Okay, we got the book opened up. Sweet. And let's kind of, well, we don't need this to be as big. Make this a little bit bigger, drain this out. Okay, cool. Let's go ahead and, or maybe I'll code. I know it's kind of unorthodox. Maybe I'll code on this side here with the book on the right. So you guys can see my full screen here. So we're back here, chapter 8. Okay, we should be good. Chapter 8. So let's go ahead and get into chapter 8 here. Chapter 7, 8. Okay, we're on the chapter 8 exercises here today. So thanks so much for being here and joining me. Let's see how these go. How about yeah? Feel free to do these alongside me. We're gonna try our best, and yeah, we're learning C here together as we do. Teaching ourselves computer science and programming independently here from books and online resources, and seeing what we can get into here. But yeah, so we've had some good exposure, about a year and a half worth of Python. Obviously with some C mixed in there, very basic, but now we're really diving deeper into C and really taking our time to go through the basics. I know we probably could skip some stuff through the book, but I'm going through and really hitting home runs over the topics that we've already been exposed to. So it's nice. It's nice to have it be kind of stuck now. It's like solidifying better. Okay. So let's get into the chapter 8 exercises. All right, and let's go here, and then we'll go 4. I in 1, 2, like 1, 2, what is this? 11. I'm not sure if this is the right syntax here, whatever. Let's just go ahead and do, I don't know, can we say that? And then we'll say make dir, chapter 8 exercise, and then we'll do this syntax here. And then, yeah. Okay, cool. Oh, shoot, dude. My bad. We're close. Close. We'll do that one more time. We'll go back in and get rid of the 2. Hold on. That was close. Alright, there we go. Now, I gotta figure out a better way to link these 2 commands together to link whatever. I'll do it off stream. Probably people that'll put it in chat and I'll look at it later, but we'll just do kind of a similar loop here, but we'll just touch a .c file in this, and I'll just put it in there because I'm too lazy. All right, cool. Let's roll. Welcome in, everybody. We're on C Programming: A Modern Approach, Chapter 8, Exercises. This is after the end of the chapter. If you haven't read the chapter yet, make sure you hit the, take a peek at the reading, either in the live stream if you want the full version, or I have a condensed version where I just uploaded a video to the channel, basically like just me reading through it chopped up, line after line. So make sure, yeah, check out the chapter. We're a book club here at the channel. We're turning into a programming book club pretty much. Make sure you got your book review. Make sure you read the chapter before next stream. All right, here we go. Let's get into this one. Number one, we discussed using the expression size of A, right, size of the array over a size of the first index of the array to calculate the length of the array, right? So the size of operator, if we remember, or the size of, right, it'll give us the numerical number of bytes that this, variable, whatever it be, will, represents. Now the arrays can be variable length, have differing length, meaning, right? So size of could be dynamic here for whatever the actual size of the array is. Now I'm not sure if we haven't learned yet. I'm not sure if it does some pre-allocation of some bytes just for an empty array, and then maybe some pre-allocation for some spaces, kind of like how Python does, where it does that allocation and then will kind of give you that buffer until you get to a certain point, and it'll give you more and whatnot. If I remember correctly, it's been a while since we read that part in that book. But then if we divide that value, so the number of bytes of the total array, by the size of one of the individual elements, right, that just gives you a numerical value of elements, right, size of an per element, versus total size. That just gives you, if you think about a deduction of units, right, that just leaves you with element and how many elements are in there. Cool. To calculate the number of elements in the array, the expression size of the array over size of t, where t is the type of A's elements, would also work, but is considered an inferior technique. Why? Interesting. Never really thought about this one like this before. So why would this be a bad idea for doing the size of a type rather than the size of the actual element? Well, what if the element... Now, the array is declared to have elements of all the same type, right? Within C. So that's something that we have to think about, right? I mean, the thing I can guess, right, is maybe the array type changes, right? And then you have to replace two variables rather than just a dynamic call to the first element that's always in it, right? Now, what if the array actually is empty? Well, you do the size of the array index 0. Array index 0 probably gives you... I wonder what would happen if the array would be empty in this case. Well, if the size of the array is 0 bytes over some garbage value, right? If it gets you some garbage value, it'll just be 0 because it's 0 over some garbage value. So it kind of like trumps that. What do you guys think? Okay, here we go. Let's keep rolling. When using the type of the type as the dean, when using the size of the type when in the denominator, when determining the size of an the size of an array, the length of an array. You now have to account for an additional variable in case of changes to the array's type rather than dynamically accessing the first element no matter what. Let's get some feedback on this one. What do you guys think? Anybody have any feedback they want to give before we go to the tree burners and the water boilers? That's what we got to call them, the water boilers. That's like their mascot. The water boilers. You guys know what I'm talking about. Chat GPT. You're certainly the right idea, but the explanation has been a tidying precision and cleaner way to think about it. What's actually going on? When you compute an array's length like this, using the size of an entire array, dividing by the one element, whatever the type happens to be. If you later change the element's type into double, the expression still works correctly, automatically reflects the new type. You're not adding an extra variable. Doing a size of int, though, in the denominator is fragile. It assumes the array is made of ints. If the array type changes...
You're not that guy.
Hey, thank you so much for this.
You? Absolutely.
Appreciate you for following along here. You're awesome. Who was that? Let's go to our social stream, or our, what is it called? Streamlabs. It's been a few days since I streamed, man. You get out of it quick. Let's see the recent events here. That was Shable. Hey, thanks for the follow on Twitch. We got the small Twitch representation. So thanks for coming in. I actually have been thinking about not streaming on Twitch anymore, but that's actually a coincidence. So thanks for maybe changing my mind. Appreciate you being here. Okay. It seems that every type is made of an... I'll bring this over for y'all. Self-maintaining. When using the size of type in the denominator and determining the length of the array, you now have to account for an additional variable in case of changes to the array's type, rather than the dynamic accessing of the first element, with array index of 0. Cool. That's my answer. Anybody got one they want to give? Hey, what's up, Sylvia? Welcome back in. Appreciate you for jumping back in. One of the OGs that have been here coming in. Appreciate you for joining me. All right, let's move on to number 2. Sorry if I'm moving kind of slow, guys. I like to be methodical about our answers and really think about them, really process them, and I find it helps to, rather than just jumping through this. It's not like I'm having to turn this in by midnight. It's a different mentality, right? It's when you're doing independent learning, you really have to shift your mindset from a rush kind of paced schedule with firm deadlines to kind of being able to cut yourself some slack while also holding yourself accountable. And there's no reason to rush through this. I don't have a due date at midnight. Like I said, I can just process it. Okay, number 2. The Q&A section shows how to use a letter as an array subscript. Describe how to use a digit in character form as a subscript or an index, right? The Q&A section describes how to use a letter as an array subscript, right? You can use like I and a for loop to index into an array. Describe how to use a digit in character form as a subscript. Okay, so is this just saying like you have an array, right? Normally you would index it like this with a letter if like you were in some sort of for loop, right? Um, so then like how would you use a digit in character form? So this is interesting. I'm gonna go to that Q&A question. Because you choose characters integers, you probably need to scale the character before you use it as a subscript though. Let's say we want the letter count array to keep track of the count of each letter in the alphabet. The array needs 26 elements, so we'll need to declare it that way. However, we can't use the letters to subscript letter count directly because their integer values don't fall between 0 and 25. That's just for this kind of niche case, right? Subtract it from A. Describe how to use a digit in character form as a index. So obviously when we do a for loop, like, for uh, int I equals to 0, I less than, some value n, I plus plus, right? When we do something like this, I is declared as the integer value, 0 through whatever, up to n. Now, it's already declared as this integer with this for loop. But what if we had like char, like character, which is equal to like we'll go like what, like 65? And so let me go like this. Let me include the, oops, sorry. Let me go, slow down. Void. I'll take this. Okay, so obviously, whatever. Nothing's gonna really take place here. But if we go printf and we call printf to the char of ch, right? Oh, shoot. Sorry. Oh, that's right. Let's say 10. Right, so we get 8. Okay, cool. How to use, describe how to use digits. I think I'm still understanding the question. Describe how to use a digit, right? So we want to use a digit. in character form. Oh, is it wanting us to like index with an actual character of like quote A? Can you do that? Let's see here. Let's do sorry. Let's just call for an int array, and we'll make it with one, two, three, right? And then let's go ahead. And let's actually, we'll make this length of 66. No, sorry. 65. And then I'm going to call a printf to %d here. And I'm going to use array A index of capital A. Let's see what happens here. Array index is oh, it has length 65. Sorry, I was right with before 66. My bad. Oh shoot, sorry. 0. So it does index into there properly. Now what if I do the C thing and I make index A65 equal to, let's just make it to like 99. Let's see what happens here. 99. Okay. We're getting somewhere. So describe how to use a digit in character form as a subscript. So, I don't know. I mean, it'll just have its ASCII value, and you can use it to index into. But I mean, what good does it do? Like, what is this question really trying to get at here? You know? Okay. Hmm. How is it digit in character? So would you have to? You'd have to like you obviously have a bound range, right? Of with these characters that they only go to 128, right? So you'd have to obviously. I mean, but like maybe you use just like the alphabet, just like 65 through whatever, just the capitals, like just the 26. So you know you have a 26 like base, right? Ah, sounds kind of interesting. Describe how you use a digit in character format. Shows how to use a letter as an array subscript. Right? We read it. She treats characters as integers. You'll probably need to scale the character before you use it as a subscript. Right? You can use the character minus a value. What do we think, chat? Okay. I think we've given this one enough compute time here. Can you sections just use a letter as an array subscript? Describe it, use a digit. Character form as an array subscript. Let's ask here, same. Let's give it my thinking. I am trying to describe how to use a digit in char form as a subscript or index. My thinking is probably weak, but I am on the line of the chars in C are treated as integers with their ASCII values. Giving us a bound range whether it be the full board or the full ASCII or just a alpha bet set. Now I'll give it like my example here. I wrote some code showing that I could index with the A into array, but I'm not exactly sure what the question might be fully asking. There we go. No, it's not weak at all. Here we go. In char, and see a char is an integer type. The character constants are integer. Let me help you sharpen the concept and also clarify what the question is likely trying to get at. Core principles. This is the sentence you're looking for. Array subscripts in C are integers, and char values are just small integers, ASCII codes. So a character constant like capital I can be used as an array index. That's it. Everything else flows from this. I've been overthinking it a little bit. What do you know? So the capital A works as an index. It's not a string and not a special it's not special syntax. It's just a representation of the ASCII value of 65, right? Oh, my bad. I meant to just pass this. Sorry, y'all. Okay, cool. So that's what we'll say. We were on the right track here. I like that. Chars in C are just small integers, right, based on their ASCII codes. So, right, it says character constants like the capital A can be used. So yeah, so characters can be used as indexes as what does it say? Subscripts. Within a certain range. Then a bound range or something. Because you don't have like unlimited characters to use, right? Let's get some feedback here. The comments basically shows the mental model, just tighten up the language. Just can be used in array subscripts within a range. Okay, cool. I think that fits the bill. We'll move on here. Nice. Okay. All right. Keep it pushing. Keep it pushing. Number 3. Not too bad so far. We're being thoughtful with this one. Let me catch up on some chats. Sorry, here, hold on. Where is that chat? I want to go to the YouTube. I need to put the past chat here. There we go. So I can scroll back. Let's see here. Right. APOC brings up a good point here. So let's say this has portability limitations as it relies on C's ASCII character ASCII integer relationship. Something like this. We might be being overkill here, but whatever. C does not guarantee ASCII either. It's not the issue that C has ASCII relationship, it's going to be specific encoding. Character constants and integer values, so characters can be used as array subscripts within the range. This is portable only when the program does not assume specific character encoding. Okay, I like that. Cool. A little polish of our words here. For a specific character encoding. Right? You can encode the characters to mean different things, I guess. Okay, so let's follow up then. So let's say, so we can encode the chars to mean different values depend. Right. You can encode characters to mean different values by mapping them yourself, but you should not rely on their underlying numeric codes unless you control the encoding. Two different ideas is the key distinction. What C gives you automatically, C gives integers as an character as an integer value, but the actual numbers depend on the character encoding. Only relative ordering and contiguity are guaranteed. This is valid if C is A through Z, right? Yeah. You can encode explicit mappings. And you can absolutely decide what character means by mapping it to this. Okay, I'm going to get into the weeds here. Let's keep it pushing. Okay, let's keep it rolling here. That was fun. Number 3. Write a declaration of an array named weekend containing 7 Boolean values. Include an initializer that makes the first and last value true. All the values should be false. Cool. So let's just go ahead and include the standard IO. um, let's do int main void here. Open this up. Let's go also, don't we need to include the standard, is it bool? H? I think that gives us access to true. Yes, it does. Okay. I think so. We'll find out. The syntax, I think, gave it away. All right, let's go ahead and try this out. So we want to declare an array named weekend, okay, with Boolean values. So bool weekend with how many? 7 are values. Cool. Let's go ahead and initialize this. So it'll set all of them to 0, which will be false anyways. So we can just set the specific ones which it wants, the first and last. So index 0 is equal to 1. And the last index, 6, is equal to 1. Right, something like this. And then let's go ahead and print. Can you print an array like you can in Python? What does the compiler do? Well, how would you even do that? You don't have a specifier for print. We haven't learned about it yet, so probably not. But probably specific values. I mean, we can always just loop through the array. So let's just do this. We'll say that the length is equal to the size of our weekend array over the size of the weekend index of 0. We're going to go for int I, which equals to 0. We're going to go up until I is less than the length. And then we'll say I plus plus. Oh, no. What we're going to do is printf to %d and insert weekend index of I. And then leave it at that. But then we'll do a little back here. But we'll say index, and then we'll insert here the actual value of I, and then we'll do this. Oh, like so. I think that'll do it. Let's find out. We'll find out, that's for sure. No. Undeclared identifier length. Oh, sorry. Let's go. Cool. I think that solves that one. Let's get back to chat here. This book could include a challenge at the end of the chapter to make it more fun, some kind of game. I don't know, dude. What more do you want it to do, man? It's like it's giving you like a bunch of exercises and programming practice projects too, problems here. These are kind of the challenges, I guess. It definitely provides a lot. It's pretty dense. It'd be like a 2,000 pages. For example, Minesweeper game. Oh, and like Maybe some like end of the book, like, or end of certain sections, like milestone projects or something would be kind of good, like big ones, big ticket projects. Okay, cool. Let's keep pushing. I think that's fine. Let's go ahead and move on. Anybody have any disagreements with that? Let us know. I think we're okay with that one though. Number four. Here we go. Number four. C99. Repeat exercise 3, but this time using designated initializer. Bro, that's what I did. Oh, okay, so maybe I should. That's what I did. Now, here's another question. Can I do this? No, you can't. The comma operator is an operator and it'll default to the. No, 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 it won't. So you have to declare each index individually. Um, that's what I already did. So, dang it. Maybe for this one, what we'll do is we'll go like this. We'll declare a size 7. We'll make it kind of we'll dummy it up a little bit. 1, 0, 0, 0, 0, 1. Oh, sorry, 1. Right. 1, 2, 3, 4, 5, 6, 7. Cool. So now it should have the same effect. Right, but it's just dummied down a little bit. Now we did it like this one, the Chad way here, and this one works even better. Okay, cool. Cool. For bool bits 7, for I 0, I parentheses 6 minus I parentheses ampersand 1. I think we've learned about this one yet. Sorry, dude. Looking a little cryptic. Bro's trying to flex. Okay, let's keep it going. Number 5. If you're enjoying the code, let us know. Appreciate you guys being here. If you guys could subscribe, if you're new here and not subscribed, just hit the button. It's completely free. Spending my free time over here doing coding projects live for you guys, looking like a fool when I don't know. So, thanks for being here and joining me. My name is Michael. I'm 26, going on 27 here soon. Got a degree in human bio and a minor in chemistry. And I work as a chemist for a biotech company where I do stuff with manufacturing and formulation of controls, biological controls. Been teaching myself how to code for like a year and a half now, a little over than that, you know. We've been learning Python for about first year and a half to introduce ourselves, and now we're starting to dive deeper into C and more systems stuff, and hopefully get like machine learning and really start to expand our projects out more. But we have a couple of projects going on that are more like full stack kind of stuff right now, so stay on the lookout for that as well. I'll show you guys what it's looking like at the end here of today's stream. I made a lot of progress on the front end so far. Okay, number 5. The Fibonacci numbers are 0, 1, 1, 2, 3, 5, 8, 13, where each number is the sum of the two preceding numbers. Write a program fragment that declares an array named fib numbers of length 40 and fill the array with the first 40 fib numbers. Hint, fill the first 2 numbers individually, then use a loop to compute the remaining numbers. Oh god. Here we go. We're really getting put to the test here. Just ramping it up. Okay. So we need to declare an array called fib numbers. Right, of size 40. And it wants us to fill the first two numbers. So we just need to basically override the next index values, right? It's already established the index values. It's 1, 0, and then 0, zeros for everything else. So we just need to compute the Fibonacci, right, which is just is the sum of the two previous numbers. And from index values 2 forward for that value, right, to fill. Okay, sounds good. If we already know what the two previous values will be, we can stop once our leading value filled, or j plus 1, is equal to the length, right? Equal to n minus 1. So let's do this. Let's say we have a int length variable, which is equal to the size of the fib numbers divided by the size of the fib numbers index of 0. Let's say for int I, which equals to 0, semicolons, while I is less than the length, less than 1, and then we're going to increase I forward. We can say j is equal to I plus 1, right? And we'll declare this integer locally here, like so. So we have j, which just leads. We're going to compute it will say if we're going to compute the value, save it on the last move forward once j hold on, I'm not trying to look at chat. I want to think it through. Let's really think it through here. So we're going to loop, and we only need to compute or loop until we're going to save the this is size 40, so we're going to save the 39 index, or I value 39. Index 39 is our last one. So we're going to stop when I is 38 and j is 39, or when, sorry, when I is 37 and j is 38, because we're going to save at fib numbers 39. So let's actually go I less than 2 here. Let's compute j1 forward. So this will automatically stop when I is on the third number from the end, right? Now we don't even need to do any conditional logic here to determine if we're at that position. So I is at, in this case, 37. J is at 38. And we're going to save at 39. So we'll compute, we'll save in fib numbers index of fib numbers index of, I plus fib numbers index of j, and then we're going to save this value, right, that we compute inside of fib numbers index of j plus 1 is equal to here. This might be a dumb way, I'm not sure. Let me think. So we have fib numbers which are size 40, and we declare index 0 and index 1 as values of 0 and 1. We're going to sum these together. So we're going to say I is 0 and j is 1 to start off. So we're going to index into there and sum those together to get 1 for that right side of that expression, and save that into index value 3. Now I guess I could just loop from, index value 2 forward until I get to the end, and just back compute the back two indexes, right? Of I less than 1, I less than 2, which might have been probably easier than thinking about it like this. But let's go and see what happens. Whatever. We'll find out, right? It's my motto, I guess. Fort for int I equals to 0 up until I less than length. Let's go. I suck at writing these. So used to Python. I'm blessed with the Python syntax simplicities. Let's find out. Let's see what happens here. Oh, not there. No. Not bad. Oh, do I have to put this in parentheses here? It's a semicolon in the for statement specifier for the less than 2. Oh, it's a comma. See, I'm trolling with this. Sorry. Oh my gosh, another one. You guys are probably like shaking your fists. What is going on? Ah, here we go. We got it. Oh no. Oh no, I think I did it. Let's go. 2, 3, 5, 8, 13, 21, all the way up until boom. Let me, we'll print, we'll say fib num. We'll say, we'll insert here a %d, and we'll go here, and we'll say this is going to be I plus 1. And this guy here. Let's try that. Ooh. Okay. Fib number 40. Nice. I think we got it. Let's go. What's going on here? Let's see here. Machine agent, machine learning, proteins, folds. Yeah, we got to get in some machine learning stuff and apply it to chemistry, biology stuff for sure. That'd be fun. Maybe we can. We've done some chemistry projects on the channel here before. Machine teaching. It already is machine teaching, man. We are the machine learning. It's the machines aren't learning anymore. We are machine learning. We're learning machine. That's funny. Cool. Y'all are hilarious. Okay, cool. I'm gonna give it my code here. I guess I could have started from uh, I equals to 2 and gone to length, but and back calc I minus and I less equals 2. I hate when it does this. I don't care. Just give me one answer. Like I don't care. Like it's so frustrating. It takes forever because it gives two answers at once. So annoying. Your current loop is doing mentally. Initialize the numbers. We treat them here. It's actually the conical YT is sought from C. Okay, let's set it up like this. So we could do it this way, or we could do it this way. For int I equals to 0, I less than the length of, oh sorry, not length function, length minus 2. We'll go I plus plus. We'll open dish up. We're not going to do length minus 2. We're going to go to 2, I equals to 2, and go to the length. We're going to compute a fib numbers index of I is equal to the sum of fib numbers index of I minus 1 plus fib numbers I minus 2. So we'll probably get the same output, right? Hopefully. Nice. Cool. Nice. All right. We don't even need to do this either. Let me get rid of this piece of crap. Why am I doing that? Let me just do this. All right, cool. Nice. Number 6. This one's not too hard. We'll take a stab at it, but we might be wrapping it up here soon. Number 6, calculators. Watches and other electronic devices often rely on 7 segments displays for numerical output. To form a digit, such devices turn on some of the 7 segments while leaving others off. Oh, I've always wanted to know how this is done. Suppose that we want to set up an array that remembers which segments will be on for each digit. Let's number the segments as follows. That's a good idea. Here's what the array might look like, with each row representing one digit. So if you want to say 8, number 8, they're all on in 8. But for the number 9, the last one is off. So this is going to give you, I've given you the first row of the initializer, fill in the rest. Okay. I'll print in this from before, so I just get this the boilerplate here. So we have a const, right, which tells the compiler that we're not supposed to be making changes to this array. Const segments, which are 10 rows by 7 columns for each row, because there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7 with the included height middle one. Sorry, there's 7 possible segments, right? 0 through 6, and then we're going to say here. You give us 1 here for us. 1, 1, 1, 1, 1, 1, 1, 0. So that gave us the 0 here because the 6 value is off. So then how does this wrap? Looks like would go like that. There we go. So for this one here, the 0 would be off. So let's actually just go, let's default this to all zeros. And then we'll bring these down for 10 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, cool. So this is going to be for the 0. This is going to be for the 1, etc., etc., etc. So for the 1, everything is off except for the 1 and the 2. Index 1 and index 2. Sorry. Everything is off except for those two guys. For the 2, the first index is on, second index is on, the third index is off, fourth index is off, sorry, on, off, on. Fifth index is on. Sixth index is off. Wait, did I miss something? What am I doing? On, off, on, on. On, off, on. Off. Oh, these are 1, 2 long, sorry. These are all off, 1, 2 long, my bad. How many miles did you do?
I just started. I just have to tell you something.
What?
This guy is so annoying. Lady's curled up in a ball, like all cozy in the heated blanket. This guy grabs her ball and goes right up into her face. And he's chewing on her ball right in front of her. Why are you doing that?
Jumping on and showing her the ball.
It's being weird as hell. Look at this. She's got 4 right here.
It's Ball Mania.
Grab your ball.
That's our Christmas
Grab your
presents. Christmas
Grab your
presents.
ball.
We
We're going
love.
out here.
Okay,
Go on the phone. Grab your ball. Come on.
perfect. Okay. So we have 1 too many there. My bad. So the 2 was on, off, on, off, on. Okay. And then the 3, right, is going to be on, on, off, on. This is funny. 4. I feel kind of silly, but whatever. The 4 is going to be off, on, off, on. Oh, yeah. I keep losing count here. What the heck is going on? Go there. Okay, here we go. 5. Sorry. Okay. Number 5 is going to be on for that one, off for this one, on, off, on. Cool. Number 6. Number 6 is going to be on for index 0, off for index 1. Sorry. On for index 2, on for index 3, on for index 4, on for index 5, and on for index 6. Only one off, which was index 1. Perfect. 7, on for index 1, on for index 2, or sorry, on for index 0, on for index 1, on for index 2, off for the rest. 8, 8's on for everything. And 9 is off except for index number 4. 3 and 4. Perfect. Using the shortcuts. Okay, cool. I think that's not all for number 6. Now, number 7 is probably going to want us to do something here. I don't know anything about schools these when interacting with LLMs. People talk about it seems like every stream it just always turns to talking about LLMs and what's gonna happen with AI. People are like, it's just such a hot topic. It's crazy. What's my experience with C? We learning it right now, bro. Not getting kicked off the computer for the night now. She's gonna make some cookies. Let's go. I asked her if she's gonna make them tonight, and she said yeah. Oh, don't you can't if you go hating on Rust in this chat, people are gonna come for you, my boy. I don't know. We have some diehard Rust fans in here. I've never coded in a day a single line, but we have some people in here that are diehards. We're getting there, Tim. We're getting there, AJ. Bro. Okay. Number 7 says use the shortcuts described in section 8.2 to shrink the initializer for segment arrays as much as you can. Okay, let's do that for this next one. Okay, so let's shrink these. So, well, doesn't really do much for this one. Like, the lines would be the exact same. I have to initialize, it'd be one less line. But I'd have a lot more code. I feel like this is like the shortest it would be. Unless I can somehow default it to going to all ones and then override the last one to 0. But see, I could either drop the 0 here and have it be inferred and then assign. Oh, well, yeah, I could just do this. I mean, that'll take care of it. Right? but it's wanting us to use initializers using shortcuts described. Okay, so any shortcut described, actually. Okay, cool. So let's do this one. We'll say index 1 is equal to 1. And we'll say index 2 is equal to 1. And then we'll just delete all these other guys for this guy. We'll shrink that one up like that. Right. For this one, okay, so for this one, hey Mohan, how's it going? Welcome back in, dude. So for this one, we could we could just assign them, right? So index 1, 0, 1. So index 0, I mean, that's the only thing we can do. Index 1. We can drop this 0. This will be index 3, right? Index 4. We can say this is index 6. And we can drop this 0, right? I mean, it's not really, it's definitely like not shorter. It's shorter in terms of numbers, but or like but it's just, I don't know. What do you guys think? Not gonna lie, I'd skip this exercise. Yeah, that's kind of how I'm feeling about this one. It's kind of like John's got the right idea. This one's, it's not really condensed at all, right? It's not any more condensed than our previous version. I'm gonna leave it. Like this one's a majority of ones. Right, so it's like it's not worth it to assign all of these. This is 4 ones, 3 zeros. So maybe if the zeros exceed the amount of ones, it's worth it. 2 zeros, not worth it. Only 1 0, not worth it. This is 4 zeros, so this is worth it. We can just drop all of these off, actually. That'll shorten those. This we have to just keep as is. And then this we can do 0, 1, 2, 3, index 4 equals to this one, and we can drop all the other zeros. I mean, it's pretty... this problem sucks. Possible. I figured if there is more than half ones, then it's not worth to declare indexes because it gets longer than just the original. Your instinct is exactly right. You're already thinking about this the way a C programmer should. Okay, cool. Let's formalize what you're doing. A 7-digit segment for ones on, write the whole row, completely use initializers, right? Oh, I'm getting closing brace, right? Sorry. Oh, okay. Trailing commas, but... One, 0. It kept the 0, right? I was just trying to condense them using tricks. Cool. Oh no, it's glazing. Restart it. Oh no, it's glazing. Once it goes into glaze mode, you gotta restart. All right, we'll quit. We'll quit. No glazing. We can't have it be glazed. Okay, so that was number 7. 8 says write a 8. Write a declaration for a two-dimensional array named temperature readings that stores 1 month of hourly temperature readings. Just copy this. Okay, so we'll go 8. Okay, so let's get out of here. Write a declaration for a two-dimensional array named temperature readings that stores 1 month of hourly temperature readings. For simplicity, assume that a month has 30 days. The rows of the array should represent months, should represent days of the month. The columns should represent hours of the day. Okay, so we have 30 days by 24 hours. Int temperature readings, right? Which is going to be a two-dimensional array of we'll say 30 days, and rows should represent the days of the month. Okay, so we'll do days, and then we'll do hours, and then we will, I guess, leave it at that. And then we can assign int days equals to 30 days, and we can say hours equals to 24 hours. Can we? I don't think we can do this. Don't do this. We might be able to. Yeah. I can't remember. Right? Is that it? Comes from the hours of the day. Interesting. Can you have... No, because an array has to have all the same type. So it's not like you can have a column out of that array in distinct indexes that could be of a different type, right? For each day represents a temperature. Right, each value is a value of a temperature reading for a specific day given by an index value. Okay, gotcha. Okay, so it's as simple as just going, we'll just change this to flutes. And these actually are ints, right? So these will be ints, and then we make a float of temperature readings for every value within these double multi-dimensional matrix. Okay, I think that's fine. This will be back here, right? Does this work?
You're not that guy, pal. Trust me. You're not that guy.
Okay.
Yeah?
And you?
Absolutely.
Sweet. I think that's fine. Hey, who is that? Shreyas. Thanks so much for subbing. You're awesome. Okay. Sounds good. Yeah, this would be, we'll make a note here. We'll say C99 plus. Right. Or we'll say, sorry, here. Like Mr. John said. Right, you can do this in C99. So you could probably get around it by using macros for everything else, right? That would work. Hey, Ray, how's it going, dude? Welcome back in, man. Appreciate you for joining. Okay, using the array of exercise 8, write a program that fragment that computes the average temperatures for a month, average over all the days of the month and all the hours of the day. Okay, that's pretty simple. Okay, so what we're gonna do is for every int day which equals to 0, while day is less than, so we need to do a well, we already know that the amount of days is 30, so while day is less than days, right, we're going to increase day forward. Is this like curse syntax to use, like kind of Python stuff here? Like day and days is usually. And then you can say for every int hour, which is equal to 0, while hour is less than hours, right? We're going to compute hour plus plus. Open that up. So it wants us to compute the average temperature for a month. So we'll say float total. We'll define this to equal to 0. And we'll say temperature readings, index of day, index of hour, plus equals, or sorry, total plus equals to this. And so that'll give us all the values totaled. And then what we can do is just do printf. We'll insert a float and we'll do an expression of total divided by the number of entries total, right, which would be days times hours. Something like this. We could say average temp, average monthly temp. Something like this. Why do new subs have this privilege when you didn't show us you're not that guy too? Oh, the sub thing? Sorry. I had to level up my stream game, my guy. Welcome. Okay. What do you guys think? Do we have any issues here? Obviously, we need some. Do we have any issues? So we declare days and hours. We do this to declare our readings. We declare a total to be a float. So I probably should remember that. For every day in the days and for every hour in the hours, we're going to loop into temperature readings for the day, said hour, and add it to the total, and then compute a average over all the days of the month and over all of the hours. Yeah, so it's not like per day, right? You don't compute an average for a day and then compute a high for a day or something like, or whatever. It's like, yeah, it's just like 1 month, right? Now I don't have any like dummy data in here, so let me set it equal to 1, 1, 1, 1, 1, and I'll do this. What we'll do is we'll oh shoot. We'll do this like a few times. So we get some data in here. And then let's see if we can run this. No. My bad. Variable size object may not be initialized. Oh, because it's a variable, so I can't initialize values within it. Oh. That's interesting. So I'll probably get 0 here. I'll definitely get 0 here, right? But it'll run, which is kind of interesting. Yeah. Ajah, how's it going? I just finished this book a few months back. It's awesome. I recommend the C primer as well for the latest standard. Yeah, we'll probably have to jump to the latest standard, and that's probably a good idea after you get like a basic foundation and kind of some old fundamentals, right? You finished the book. That's quite the feat, my guy. We're only on page 200 here. We've been going for like a month on it. It's a grind, dude. It's a grind. This book is dense, but we're getting good practice, and we're only on arrays. We haven't even learned about like memory and stuff yet, so I feel like we got to speed up, but honestly, I don't think we need to because it's like whatever. Oh, got a typo here. Average. Sorry. All right, let's get some feedback on our code here. Give me some feedback on my code for average temp in the month across all days, all hours. Your logic is correct. There's most of correctness details. Initialize a float. This does not do what you probably think in C. An empty initializer list is not standard C. Some compilers may accept it as an extension, even if accepted does not guarantee zero initialization. If your extent is to initialize it as start with 0 at all temperatures, declare 0 initially as the first value. Okay, I remember that from the reading. So if we're going to declare an empty thing here, we should probably do all zeros here. Now, can you just do a semicolon here and delete this and then it'll do it inferred, or do you really need to specify 0 there? The average calculation is mathematically correct. Cool. You want to be extra explicit but not required, but your version is fine. The days and hours, it's not a float really, but total is going to be what do you guys think? Oh, cool, John. We can link together the commands with and there. Okay, that'd be cool. We should do that. Okay. Yeah, for sure. The Modern Approach book was the one that actually taught me C well. The great part is that because you've covered the fundamentals in Modern Approach. Yeah, exactly. I'm really trying to get a really solid fundamental. That's kind of what I did with Python. I really grinded through the nuances of those, elementary fundamentals before really leveling up. So I didn't really have to think about beginner stuff while I was trying to learn harder stuff. In theory, like relatively. Okay, we're almost there. Let's keep pushing. Number 10. Write a declaration for an 8x8 char array named chessboard. Include an initializer that puts the following data into the array. 1 character per element. What? Write a declaration for an 8x8 char array that names chessboard. Includes an initializer. Oh, okay. So let's just do this, and then let's go ahead and get rid of this. Get rid of this. Here, we'll initialize this R and B Q K B N R, and then we have pawn quote. Hold on. Okay, and then we have you do space period space period space period space period, like so. And then the same thing, but oh, this is annoying. These problems are a little bit tedious, huh? But it's whatever. Then space. Oops, sorry, not double quotes. Python, what have you done to me? What have you done? Okay, oh, it's giving me doubles. That's why on default. Okay, there we go. Now here we're gonna do single quote space, and then we're gonna copy these. Cool. And then it goes 2 more sets of these. Copy these down. And then it goes all pawns but lowercase, or uppercase, I mean. This is so tedious. Should I have done this a different way? I don't know. Is this really what it wants me to do? Is just get practice kind of initializing an array? Kind of whatever. And then this next. With R, N, B, Q, K, B, N, R. Right, and then what we can do is this is going to be an 8x8. But we don't want to predefine. Can you? Yeah, I think you can. You can do with variable length arrays. So I think you could do like that. And then the char. Could I put the following data into the array char per element? And then let me. I'm going to take my double for loop here, and I'm going to go here. Whatever. This is so annoying. We're going to copy this. We're going to insert into here the value of temperature readings. J. Okay. Oh. That's that. When you get to the C primer or something else, you can just skip to the updated section. Nice. We haven't learned about pointers yet, unfortunately. Yeah, exactly. As Silva just mentioned, we're abiding by the laws of the book. We're kind of going at that pace. So yeah, we know about them in our mind, but we're abiding by that. So let's go ahead and run this. We're almost there. Thank you guys for being here with me. If you guys are enjoying the code, appreciate you guys here. GCC -0. Let's do it like John said. Can't do that. John lied to me. I thought it gives it a name. Oh, you can give it a name and compile it in the same thing, maybe without giving it the name first. It kind of comes inferred by the compilation afterwards. Dang. I think John lied to me. John, why'd you do that? Alright, let's go here. Oh, sorry. Did I do it wrong? I might have did it wrong. What am I doing wrong here? I'm in 8. Lunch chapter exercise 10. Wants me to do -O file exe. Oh, you have it there. I just missed it. My bad. Okay, what is going on? Oh, we'll tie these together and do. Oh, let's go. Yeah, we go space dot space dot space dot dot space dot space dot space space dot dot space space dot space. Yeah, because you get double spaces, then you get double dots. Yeah, because it alternates. Right, you get double dots back to back, and then sometimes you get double spaces back to back. Okay, perfect. That did it right then. Nice. Nice. All right, last one here, boys. Leave a sub on the stream if you enjoyed the content so far. Last one. Last one. Number 11. Write a program that fragments write a program fragment that declares an 8x8 char array named checkerboard, and then use a loop to store the following data into the array, one character per element. Okay. I copy kind of our boilerplate from here. So we have an 8x8 array. I guess we'll declare to be 0. We're going to loop through all the values within the 8x8 array, and we're going to okay, this isn't that. Okay, so we're going to say if I plus j mod 2 is equal to 0, then what we're going to do is say we're going to say that this isn't temperature, this is going to be a checkerboard. Checkerboard index I index j equals to quote b, else checkerboard index I index j is equal to quote r. Can we leave it at that? We'll find out. I keep saying that. Oh my gosh. Oh, I keep doing that. Oh, I don't think I'm printing. Oops, sorry. And then let's go through. I'm gonna grab this again, and then we'll print checkerboard index I and j. What I'll do is I'll say if, or I'll print all of j, and at the end of the loop here we're going to print a \n. Oh, sorry. Python! BRB, RB, RB, RBR, RB, 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 BRB, RB, RB, RBR, RB, 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 BRB, RBR, RB, RB, BRB, RB, RB, RBR, RB, RB. Nice. 8 by 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Nice. Sweet. Nice. How's that sound? So hold on. So if I set RB, 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 Arby's, 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 Arby's. We have Arby's, we have meats, we have meats, we have meats. Pause. Okay. So if I initialize this to R, I forgot, will it default initialize, will this or any value if int array and it's a 12 and int all vowels to that? Now all the remaining elements are 0 initialized. So maybe instead of computing like the else clause here, you just assign it, and then if it is, you override it. I don't know, what did you mean? Oh yeah, you're saying just assign it by default. Well, it's going to initialize zeros for everything over here. Right, so because this is what I'm doing, let me take this. Because doing this, may you could just do this. So this line does 0 for everything. This declares the array but does not initialize it. In C, that contains the array are indeterminate, basically garbage values. Okay, so we've initialized it in memory somewhere. We've captured spaces, and there's stuff in there from previous computation or whatever. And then we're going to come in and just fill in to this place. Got you. Yeah, if by putting one single R there, it defaults all other values to 0. So I would have to initialize all to R up front. Now I could do this and get rid of the else, right? And make it like this. So like it always does this, but this will, is this, oh, let's ask that question. Is it faster to always assign R than logic if, or use the else line? This is a micro optimization. Yeah, it doesn't really matter that much, but let's figure it out. Come on, move. Versus this. First version always writes R and then overwrites it with B. Second version does this. So you do duplicate work in this case, I think. So hold on. Before I read further, I think you would do duplicate work half the time rather than a logic check. Exactly. In your first check, every element goes into R. Roughly half of the squares would override immediately with B. So you're doing two elements of work in one go rather than just doing a logic check to now they are both O of 1, right? So it doesn't really matter that much. But what is better? Roughly half the elements overwrites to 2 instead of 1. It's 2 writes instead of 1, which is tiny, slightly more memory traffic. The if else, one element, one write per element, avoids unnecessary overwrites, column one branch, use the if else version probably. It's probably just more universally accepted, right? What's going on? Come on. Yeah, we'll keep it like that. And we'll make it syntax nicely. All right, you guys, cool. Let's go ahead and push up these exercises to GitHub. Remember, these exercises and all of my notes can be found on GitHub. I have really thorough notes here you guys can get access to in Markdown. You can just go Shift Command V in VS Code and see it here. Really nice screenshots and examples from the text. Real nice definitions taken out. So it's really like really nice Spark notes, honestly. I would love to have them if I was learning this. So we'll go git add here. We'll commit. So you finish complete chapter 8. 8 exercises. Nice. Good stream. That was a good productive stream. I'm feeling good. I'm feeling good with loops. I'm feeling good with multi-dimensional loops. Obviously having that background in Python where it's a little bit easier to write these helps. So coming into a little bit more tricky syntax, but the same kind of overall concept is still there. But we've got some good practice and solidification being able to solve these ones. So next time we'll jump into the programming projects, or probably what we'll do is take a stab at a project stream and work on the Bitter Linen project. So I want to show you guys the front end here. Let me just take, I'll end at 9:30 my time PST, so 3 more minutes. Let me guys just show you really quickly my Bitter Linen front end. Let me flash you my front end so you guys can see what I've got so far. So let's CD into the client. I've been building this on and off stream for a little bit now. This is my small business that me and my girlfriend run. We're expanding into be kind of more of a tech-based clothing store where we post clothing. Our products are still physical, but a lot of our administrative concepts are technological and ran with code and custom automation. So we'll CD into our Bitter Linen app here and npm run dev here. So this is what I have so far. This is for my hero page. This is what I've been putting together. Please let me know your opinions of what you think. I really would like your opinions so I can get some perspective on what you guys think from like users and whatnot. So I put together some components such as a footer, obviously this kind of hero page section. I went ahead and designed kind of this abstract kind of art, kind of grunge 90s rock poster mixed with Vogue fashion kind of look. I think it looks really kind of clean with this kind of like blue hyperlink text kind of feel. Yeah, it can be a little bit difficult to read, but kind of has that visual tension on purpose to kind of give it that kind of feel. I didn't really want to add any elements behind the text. I thought about it, but I wanted to really showcase the imagery, and maybe even I'll add in some more elements and expand this out to maybe like a really wide collage over time. But for now, it looks clean, kind of just a simple one with like a coming soon. So it's just like a little, I'm probably going to go ahead and push up the branch off the project into a main and then or from main into a dev and then push up the main, which will just be just have these endpoints just for the overall homepage. So people can actually visit bitterlinen.com, the endpoint we own, or the URL we own, DNS, and we can people can just kind of visit the preliminary page here. But I also went ahead and I have a footer here. I went ahead and added our logo. I went ahead and made a little logo here, which looks nice, kind of a custom typography, kind of festival poster kind of style typography kind of thing. Looks nice. I like it. Um, we'll see how long. We'll see. I might tweak it a little bit here and there, but I think it looks nice for the general concept of what we're going for. And then obviously I haven't done anything with fonts on the page yet, so this is all just default Arial font or whatever. But this is just a basic footer here. So please let me know what you guys think about these components. I'm not sold on the footer. I might change this up to be a little bit more like, I want it like more like, maybe a little bit more, not, it is clean, but it's not, it's kind of more, it's a little bit like, I don't know what the word for it is. It's not childish. It's not. It's a little bit adolescent. It's a little bit just like too basic. Like it, I kind of maybe want to have a little bit more abstract. Not nothing where the flow gets like distracted from, but just to have a little bit more feel to it. But what I also have is what I also did is I have this feature for mobile. So it shrinks down, everything fits really nicely, and boom, when you shrink from large downward, you get this alternative image. So on mobile view, rather than having this kind of be shrunk down and it kind of like difficult to read, what I did was I just created an alternative image and displayed that one in its place for the mobile view. So this is what it would look like on mobile. So it looks really nice. It expands all the way out rather than just being this really small and whatnot. Pause. Anywho, so I got to work out some other features. I think what I'm going to do, first things first, I'm going to shrink this logo down. I'm going to make this smaller. This logo needs to be smaller. I think that I'm going to make this logo smaller. I'm going to make this text a little bit bigger. I'm going to probably redesign how I'm doing this. And obviously, probably just the whole footer, honestly. So, thank you guys so much for being here for this stream. We'll do a design stream tomorrow. So make sure you come back tomorrow around 7 p.m. PST, where we'll take a stab at keeping up with our Bitter Linen project, both our full stack project. We're writing with React, Tailwind, Python, Fast API as our backend, and really trying to learn about full stack products and design and product design and what we can do, digital product design and all that stuff. So thanks so much for being here, and I appreciate you guys. We'll be back tomorrow, so subscribe and like the stream. Thanks, guys. Peace out.